what is face recognition? That is what we will understand first, and what are the processes, how we are going to execute this, and the code required for that. As you remember last time, object detection started finding cat, dog, bicycle, person, all that, right? So that is detection. When we talk about face detection and face recognition, these are two different things. So face detection is about just finding a face or detecting a face. There is a photograph. In that photograph, is there a person? But whereas recognition is to actually identify the person. So both face recognition, face detection, object detection, all these are parts of computer vision. When you point the phone at the face, if the phone unlocks, that's already face recognition, right? So you're probably already using it. Most of you already know the meaning of face recognition. What are the different applications of face recognition? So it's a very useful thing. Now it is already invaded into our lives. We are doing face recognition in so many places, both for personal uses or even for company or organizations are using it full time. We have surveillance cameras in, for example, police, law enforcement, detecting people. If your apartment complex, somebody has come to your house, if it's a known person, unknown person. Well, your mobile security, if you have parents, if you have children, if they have a phone and you have the parental control, you can actually use the same face recognition to achieve some of those things. Even in airport security and all, we are using border control, security gates. If there's a known terrorist, terrorism detection, racism detection, all these places we are using face recognitions. And then there is social media tagging, or if you go for some trip somewhere, take pictures, you can tag your friends. So if you notice that Google Photos and all automatically starts detecting your face and your friends' faces if they've already been tagged. Apart from that, it's used even in retail for better customer experience. If a returning customer has come, it can get your preferences and then show you what you like, what you don't like, right? Apart from that, the other one is attendance and time tracking, which is probably bad or good. Depends on who's looking at it. For companies, it's good because it helps them do time tracking. For employees, maybe some of them, it's too much of invasion, right? Like even for 20 minutes or 10 minutes, if I have to go out and come back, my time is tracked. How is it doing it? You don't have to swipe RFIDs. You don't have to do your biometric. You just walk towards the door, it automatically opens. And then it also puts a timestamp. If you keep going 10 times, 20 times out, everything gets recorded because your face recognition is recognizing that it is Karthik or Shashank or whoever else is there, right? These are just some of the examples that I can give. There is more and more usage in so many sectors, healthcare, manufacturing, and many other places. Today's session, before jumping directly into code, let us understand, because there are a few nuances or elements involved which you need to understand before we directly jump into code. Yeah, but today we will do some hands-on for face recognition. I want you all to write the code. We will try to copy paste the code in the chat window or on the YouTube comment section so that you will be able to get the code and run it. If you're not able to immediately run the code while I'm showing this, it's no problem. You can pause, rewind, go back. Sometimes it may go a little fast, right? So there are two parts in face recognition. So the first part is training, right? So and the second part is prediction. Training is creating a brand new model which does not know any faces by giving them some photos and telling the model that these are my friends, the people that I recognize. Please make a note of them, extract their features, understand them, and then later on prediction is where when they come in front of the camera or when I upload their photo, it should recognize. Yeah? So both are two separate activities. You can either write everything in one single file, or you can do two separate files, one for training, one for prediction. That's what I recommend, so that every time you run, it should not try training it again and again, right? So let's look at the steps. First is training. How do we train a AI model or a CNN model to recognize faces? There is the very first step, that is data preparation and processing. Yeah. So the data preparation is about collecting the data, curating the data, and ensuring that the data is all in the right formats and places. So let's say I want to detect faces of some of my friends. There's me, that's Praveen, Sagar's photographs, I collect a few. Then I want to detect Shashank, so I'll ask Shashank to give me his photos. I'll ask Rakshita to give some photos of her. I'll ask Karthik to give some photos of him. So once they give all the photos, right, I will put them in individual folders. I'll create one folder called Karthik, one called Shashank, and put all their photos there. The first problem will be in data preparation that they're all giving from different sizes. Some will be a very big resolution, some will be smaller resolution. So I have to resize them all. The second thing is, in one of the photos, let's say Sagar is given a photo where he's standing very far off. There's somebody else standing in the photo, or there's a building, there's a bicycle, there's a motorbike. So I may want to crop a bit and remove some unwanted information. Some things I cannot, some things that I can. So all this becomes a part of data preparation. Yeah. So for you to collect these photos, I want you to put it in some folder in a specific format. Just a second. Yeah. So I would suggest you to create a brand new empty folder called face recognition in your computer, in your Mac, in your Windows, in your Linux, wherever you have. Create an empty folder, call it face recognition or face rec, whatever you want to call it. Yeah. Inside that folder, I want you to create a structure. Create a folder called faces, and in the faces folder, you create all these, you copy all these folders, like what I just talked about, Praveen, Sagar, Rakshita. If, for example, you want to do it in your house, you're like your dad, your mom, your wife, your kids, whoever is applicable, create folders with their names and put their photographs in those folders, so that when the code is reading, it will say /faces/ Karthik, for example, /Praveen, for example, and image names, don't worry about it. You don't have to name it in any specific format, as long as they are valid image files that Python can understand. If it is some very new format, some CR2, something that is taken from a Canon or Nikon, raw photos with high resolution, it may not be able to read. So make sure in your data preparation activity, you also collect the valid formats like JPG or PNG, those kind of images. Yeah. Now that we have all these folders and we have kept it there, we can start the activities. So what I did, I have put 5 folders: Abhiram, Chirag, myself, Praveen, Sagar, Sujay. These are 5 folders I had created, and this is how it looks. This is the face recognition folder, this is the faces folders. Don't worry about the other files that you're seeing, because I took a screenshot later. This is an old screenshot that I have, but typically this is how it will look. Yeah. So in the data preparation I was talking about, when you get the raw photos, initially I was telling you may have to crop. Another good idea is try to keep them all in the same size. If it's 160 by 160, it's good, it's better. After cropping, if you want to resize them, if you want to add more types of, if you don't have enough photos and if you feel like I want to increase the accuracy, you can do augmentation. Augmentation you can do manually by rotating the photograph a little bit, flipping it horizontally, flipping it vertically, not vertically, that's not good, flipping it horizontally, making it black and white, zooming it a bit, zoom out, zoom in. You can also write code which will do the augmentation for you. So what it does is, if you have only 5 photographs and if you call the augmentation method, it will create almost 50 photos. One, it will flip all the 5 photos and you'll get 5 more photos. It will make black and white of all the photos, you'll get additional 5. Like that, 5 plus 5 plus 5, you get almost 25-30 photographs. That will help the model train better. Yeah. So after data preparation and processing, right, the next thing we have to do is we'll have to do first face detection in the photographs. Right? In one photograph, the person may be standing to the left corner top. In another photograph, the person may be standing in the right bottom or in the center. Some may be fully zoomed, some may be zoomed out. So we need to detect and crop that face. For that, we will use one library called MTCNN. Yeah. So this is only to detect faces, not recognize faces. As I mentioned earlier, detection is different from recognition. So this is what happens when you give a picture. It will say that I detected a face. It will put an exact rectangle around the face. How does it do that, right? So MTCNN is trained on thousands of images. It could be different samples of people from different ethnicity, different background, Asians, Indians, Africans, Americans, all different photographs have been given and trained, and faces are being detected. So what it does is, it knows, given even a photograph with a lot of people, it is able to start detecting faces and start putting boxes around it, and it will give a list of all the faces that were found. Typically, if you go to your Google Photos and all, and you click on people and pets, you will see all the people who have been detected. Yeah. So that's what MTCNN does. It will only detect a face and not recognize the face, because it does not know who that person is. We have not yet given information. For MTCNN, everything is a face. That's it. My face is also a face. Sujay's face is also a face. Abhiram's face is also a face. Right? That's how it is. Once it detects the face using MTCNN, right? That's when the next step is, we have to extract the features. So what is feature extraction, and what are we going to do for it, right? So we'll be using a library which is ResNet, or ResNet based. Many of them are there: ResNet 50, ResNet 100, Inception ResNet. So, ResNet is a very powerful and popular library, and there are many more, right? And some of them, like ArcFace, InsightFace, all these are trained with a ResNet type of base model, and you can definitely go with ResNet. There are many other models also that you can use, and architecture of ResNet, it looks like this. Don't worry too much if you do not understand some of these. If you are new to CNN, if you are new to computer vision and all, you don't have to worry too much. You can revise this later. If you remember, we have covered about CNN in my previous session called computer vision and object detection. I also have a video totally about computer vision, CNN. What is CNN? How does it work? But just to recap, right? ResNet is also a deep convolutional neural network. So what happens in a convolutional neural network, right? First of all, we add something called as filters. We send a face. The face gets converted into a matrix of numbers. Like if I send a 24 by 24 pixels picture, it will create a matrix of 24 rows and 24 columns. In each of those matrix number column and row intersection, it will store a value. What is that value? That is the intensity. Every color, let's say if it is black and white, 0 to 255 means 0 is black, 255 is white. So anything in between is dark gray, light gray, medium gray, like that, right? So it starts putting those numbers in the matrix, which is 24 by 24. And then the first thing we do is called filters, right? If you remember the CNN or the old one, I don't want to spend too much talking about CNN here, but first thing is, it converts your photo into a set of numbers, which is intensities. Then it will multiply it with something called as a filter, which is a matrix of 5 by 5 or 4 by 4. Think about it like this. What does Photoshop do when you apply any filters? It adds a blur or an edge detection. That's exactly what here also it is doing, but it does its own filters, right? For it to understand, it will multiply the whole face numbers into a matrix, and then it gets an output, and that's a filter. By applying filters, we are able to extract features. For example, if I am able to do edge detection, I'll be able to exactly mark where the eyebrows are, where the eyes are, where the nose is, where the mouth is, right? It draws a line around all the features of the face. So here also in CNN, in convolutional neural network, it applies the filter for extracting the features of the face. So let's understand what is feature extraction. If I see a car and somebody asks me to explain what is that car, what is a car, can you explain me what it is? So then I'll say, okay, a car looks like this. It has wheels, it has 4 wheels, it has a windshield, it has a body, it has 4 doors or 2 doors, it will have seats inside, there's a steering, there's a bonnet in the front, right, and there's a top. So I divide the whole car into different pieces and parts, features, right? That's what I understand a car in terms of features. For a computer or for a AIML model, it may not be the same. It will not say, okay, this is a tire, this is a windshield, this is a bonnet. For it, it will be all numbers, and they call it embeddings, for example, right? They convert it into embeddings. It will look at it as triangles and circles and squares and parallelograms, trapeziums, basically formulas. A circle is pi r square, right? Length into breadth into height, or length into breadth, or a square. It starts converting all these parts into features, which we don't know how it internally works. We'll leave that to the neural networks. It is generally a black box. Of course, we know if we go deep into it, but it's all about numerical calculations, right? So here also in ResNet, it's a CNN, but it's a deep CNN, which means many layers of convolutions is happening here. Apart from your, taking the input, we do zero padding. We do zero padding, which means in the given matrix, we add zeros all across by increasing the size. A 4 by 4 matrix now becomes 5 by 5 matrix, which means when I slide the filter or multiply the matrix, I am able to get a little more extra movement from left to right. Okay? That is why we add some zero padding. Then we do batch normalization that will adjust the weights in a batch instead of one by one. Activation functions I might have mentioned in the past. I also have a video on activation functions, what they are. ReLU is one of the best here for CNN. What it does is reduces the dimensions. It will only keep the most important features like eyes, ears, nose, some of the parts of the face and all. And if there is a bicycle in the background, it doesn't have to remember that. So it will remove some of the things that are not required, and that's what ReLU will do here. ReLU will actually bring in non-linearity. Apologies. ReLU will help me convert a linear equation into a non-linear equation. Max pooling is what will remove the unwanted extra things by picking only the important ones. Then the sequence of convolutions continue, right? Every time a convolution runs, it runs a filter, it adds one layer of convolution and extracts more features. There is something called as ID block. It's something I don't want to bring in right now because it's a little complex. I'll give a very high level idea of what it is. Identity block will help ignore some unnecessary things. If some changes are not required to be made, it will skip that process. It's like this. I have a manufacturing floor where there are multiple conveyor belts. Every time a product has to go through a phase, something will be happening, like it will add a paint, it will screw something, it will fix something else on the parts. Now let's say there is one process where it cuts some extra things that have come, or some dripping paint and all that stuff, it cleans, but somehow my process is so good that those things are not happening. Then I don't have to do that process. I will skip that process and directly send it to the next step or the final step. This will save time. So ID block is used in ResNet. It's a very good architecture. And then it continues. Finally, we do average pooling and then flatten it, typical neural networks, which we have covered in the past. And then finally, it will do the classification or generate the embeddings as we need, and it moves on. So that was a horizontal image. So I'm also showing it as a vertical one. As you know, for feature extraction, non-linearity, reducing the dimensions, and also to preserve the input dimensions, that is the ID block. So after that, the next thing we want to do is save the embeddings with the labels. So so this is something, it will be good for you to understand. This is very good and interesting. How, if you've always all been wondering, how does the computer actually recognize my face? As soon as I come in front of the camera, see, one times I have shaved my face, sometimes I have not shaven, sometimes I have a mustache, or sometimes I've had a haircut, I've had a long hair. Still, how is it able to detect or recognize my face, right? I'm sure you all have this question all the time. So it's very interesting how it does. I'll explain that with the help of embeddings and labels. So when a photograph is given to the neural network, like I was mentioning, it will convert all that to pixels, and then it will do various things like adding your filters, max pooling, average pooling, all those things it will do. Final outcome will be, it will generate a vector of numbers. What does that mean, right? What is this vector of numbers that this black box or the neural network will do of the face? Now let's say this photograph belongs to Sagar, right? Now Sagar's face will be taken, converted to a matrix of numbers first, then it will be multiplied with the filters, 3x3 filters, edge detection, blurring, with all that it will start separating out all the features in the face and convert each of those features to embeddings. Now embeddings looks like this. This is just a sample, this is not the exact same numbers, but you'll be able to see and understand that there is numbers like 0.25, 0.43, 0.66, all these numbers are there. Each of these rows represents a person. For example, there's this girl, I don't know, maybe Rakshita will take your name. So when your photographs are given and trained, it will generate an embedding 0.78, 0.09, minus 0.05, 0.444, something like that. Yeah? Now, this is what gets stored in the model, this embedding in your model file, right? But next time when Rakshita, you come in front of a camera, what happens is these numbers will get generated again. It will capture your frame, the picture, detect the face using MTCNN again, convert that to a matrix, send it to ResNet, asks it to do feature extraction, go through the whole CNN cycle. Finally, it will generate the embeddings, and then the embeddings got generated, and this embeddings, all these will be compared. So for this, it will do something called as a similarity search. So similarity search means it's not an exact search. In computers, even 2 is not equal to 2.0 because one is integer, other one is decimal, right? So similarity search means if I say sofa and somebody says couch, it will say, yeah, we have a couch, right? So that's, both are similar. It's cosine similarity or angular distance between the two. That's what it is. Similarly, here when Rakshita comes in front of the camera, the embeddings that get generated will not match any of these numbers, but it will be 0.76, 0.08, minus 0.0004, for example. Instead of 0.444, it will be 0.435, right? But you see how similar it is. If you get the embeddings of the new photograph and compare it with all these others, which is the closest one? Which photo resembles the most? The farther the distances are, the lesser the confidence. When I run the code and show you, you will see the confidence percentage on top of the rectangle. You will be able to notice what's happening there. So this is how embeddings are getting generated. When I give a photograph, the neural network does all its run activities, finally gives me out embeddings. Yeah? So now we will save all these generated embeddings with the labels. Now what are the labels? We'll write code in such a way that I'm not going to keep saying the names again and again. Okay, this is Shashank, this is Raj, like that. We have simply done something by giving the folder names same as the name of the person, right? So we will take the name of the folder itself as the label. So first photograph, it picks up Praveen. It goes through the whole process. In a loop, 5 photographs are there. All 5 it will read, generate the embeddings. It will save it as Praveen because it takes the label as Praveen. Next, it will look at Sujay and goes through all his 5 photographs, one with beard, one without beard, one wearing glasses, one with a different hairstyle, short hair, long hair. All of those, it generates embeddings, takes an average, and then it will put a label called Sujay. So this goes on for all the data. If you have 10 folders, it will go through all 10 folders. If you have only 2 folders, it will take only those 2 folders, 2 people. So while we are speaking, while you are listening, I want you guys to open your VS Code, create a new folder and open that, and inside the faces folder, add one folder with your name. Even if you have only one photo of yours, I'm sure it will not be difficult to find your picture. Just find a picture and then you add that photo in that folder and then run the code. If it runs and works, then you can add all the other photos of your friends, your mom, dad, brother, sister, whatever, and you can show off. What I want you to do is, at the end of this session, I want you to know how to do this. Run the code, open your laptop, carry it around in your hand, and keep showing people that, hey, look, it's recognizing my face. Go to your dad and say, Dad, look at the camera, and suddenly it will tell their name, right? Srinivas, whatever, right? So like that. Once the training is done, the embeddings get saved with the labels. The next step is prediction. Now prediction is easy. Prediction is very, very easy. You don't have to do too much of thinking or understanding here. It's the same process. The embeddings that we saved will be in a file called .pkl file. I'm saving it as .pkl, pickle file. So I'll call it as my friends faces or friends.pkl or something. So in the next prediction phase, I will first step do is load the saved model. I'll say friends.pkl and it gets loaded into memory. Now after that, I will write code to open the camera with OpenCV, cv2.capture, right? Then the live stream is capturing and sending it to the model. If I come in front of it, it will do a face detection first with MTCNN, and then it will send my face embeddings to ResNet, the trained model actually, the .pkl file. From the pkl file, it will compare the embeddings that ResNet found, and then it will say this is Praveen, and it will also say it is 80%, I'm sure this is Praveen, confidence levels basically. Yeah. So we'll do that. We'll load the saved model, and from a live camera we will predict the faces. I'll show you how to do that today, and you guys can also follow this route. Yeah. So the steps are, first you detect the face, generate the embeddings, and match. Yeah. So when I say match, if you remember, I was talking about the embeddings here. This one, the match, what it does is the given new test face. Let's say I take a selfie and give it, or let's say I come in front of the camera live, and the program is still running. What it does, it will start searching in the stored faces, the pkl file or the embeddings that we stored somewhere, and you can see that this person's face expression is different. He is a bit shocked or surprised, not smiling or anxious, something is there, but still here there's a smiling face in the stored faces, but it's a match. It says that, hey, I found you, right? Whereas this person is a completely different person. So it's a 22% match. These people, they are also not a match. Yeah? So that's what happens. Now just give me 1 second. All right. Let me. Okay. All right. So let's look at understanding the code. Yeah, the very first step I want you guys to do is install the necessary libraries. Yeah. 1 second. Yeah, that's better. Yeah. There are two ways. One is you can install each of these libraries one by one, or you can put them all in a requirements.txt file. I will share all these files and source code on the YouTube channel link so that you can download and work on this. The first thing is pip install TensorFlow, Keras, VGGFace, MTCNN, OpenCV, scikit-learn, NumPy. So I think you already know some of these. In the last session we did this. Let me just get back on camera. Yeah. So what we did last time, we installed already TensorFlow, we did Keras. You can install VGGFace today if you have not already have it. Then we have MTCNN, yeah, and OpenCV you would have already had, scikit-learn, NumPy, all this. If possible, I'll try to copy paste the code. That's what I was trying to do while I'm speaking here. If you put all this in requirements.txt, you can just say pip install -r requirements.txt. Yeah. Now let's see what next. Okay, once all these libraries are installed, I will open my VS Code and show you guys the code. But let me explain some of the sections first, and then we'll go to the code. Yeah. So the first is import OS. So why do we need OS here? It's very it's simple for you to guess. We have all the files kept in folders. Each of these folders are in another folder called faces, right? So these folders we have to go through one by one in a for loop. So for that I will use OS. OS will allow me to talk to the folders and files, get the names of the folders, get the names of the files and everything. Then NumPy as NP. Almost every Python program I've written, I've almost always needed NumPy. You need it for all the matrix multiplications or the other libraries needed. Then Python image library, we are importing the image class so that we can do any resizing, cropping. Once you capture the image, get the frame out of it. For all that we need this. Yeah. Then for doing normalization of the data, this is basically data pre-processing that I mentioned about. We are talking about your resizing, cropping, or any other augmentation. Many of those things we can use the pre-processing library. Yeah, and we have support vector machines from sklearn.svm, import svc, support vector classifier. You might have seen this last time in object detection. Same thing, it will do classification. Like we want to say this is Praveen, this is Sagar, this is Abhiram, this is Somu, like that, right? So, and then we're talking about the ResNet and MTCNN. So, in the ResNet I'm using Inception ResNet v1. It's very good. You can definitely use the same. And then we'll be needing torch, that is PyTorch for the FaceNet PyTorch. And then we need joblib. So, this joblib, main task for this is the pickle file. Joblib will save my embeddings to a pickle file, and then in the prediction, joblib will help me open up the embeddings, like load the embeddings. That's what we are doing this for. So once we import all the libraries, while I'm showing the code, I want you to know what we are doing. So we'll go through some of the key pieces in the code, and then we'll continue. Yeah. So first thing is, I may be using a gaming laptop or a GPU laptop, high-end, like some of you guys have gaming laptops, so you can definitely take advantage of the GPU. Or I may be using a regular, or you guys may be using a regular laptop without a GPU. Then also it should work, right? So this is the first task. I'm saying device is either GPU or CPU. How I'm doing that? I'm using PyTorch to check. Torch.device return CUDA if is available. Else return CPU. So my device will be either CPU or CUDA, right? Means GPU or CPU. That's the first task I'm doing. Next, I have to create a object of MTCNN library or class, right? So it's very simple. I'm creating a variable called detector. That's the object, and I'm saying create an instance, create an object of MTCNN, and I'm passing some default values, which is image size will be 160 by 160 and margins of 20, and I'll be using GPU or I'll be using CPU, the device, what I just returned from here. Now I'm creating another object called embedder, which will help me do embeddings, and I'm using the Inception ResNet v1 class that I talked about earlier. And I hope you guys know the meaning of transfer learning. Like if a person is leaving a company, we do knowledge transfer process. I hope you're all aware of that, right? Same thing, whatever that person has learned, the new person should not start from scratch. Let them transfer all the knowledge, and then this new person will start doing their new jobs. Similarly, if I have a pre-trained model like VGG phase, VGG is one of the best deep CNNs, I will load that. On top of it, I'm going to be training my model using ResNet. Alright, so that is how we configure the device. Next, as we talked about in the previous few slides, we have to take the given image and generate the embeddings, for which I'll be calling the ResNet and creating the embeddings and all. So for that, first I'm creating a variable called face, and MTCNN's image.open, and I'm converting that to RGB, because again many of these OpenCV and many other libraries, for some reason they use BGR format, not RGB. We all understand color as red, green, blue is the combination. Like even if I have to go to a paint shop and get a specific colored paint, when I show them the color, they will type in those three numbers. One is red, how much green, and how much blue. Like if you just do only red and green, I think, what do you get? Or like if you do green and blue, you get probably yellow. I mean one of those colors. I'm bad at colors. Yeah. But if you do red and blue, you may get a purple or a violet or one of those colors. If you do red and green, you may get a yellow or orange, one of those. So like that, right? Now you just have to convert that into BGR. The first number will represent blue, second will represent green, third will represent R. I want you guys to try something. Don't add this line, okay? Don't add this convert RGB. Directly skip the conversion and see what happens. Very funny. It might still work, but when the camera opens, our faces will be looking like, have you seen the movie Avatar? The blue faces? Well, I've seen when I was training for one of my other projects, I had forgotten to add this line, the conversion. and me and Anant and a couple of other people who I worked with, all their faces were coming in blue like this Avatar movie characters. So yeah, first step is to do .rgb, convert RGB, and then there may be a case where somebody has uploaded an image, but it has no face visible, right? Like maybe he uploaded 10 pictures, in that in one pic he or she is behind the tree, in the next photo they have come to the side and saying hi, and again they have gone back behind the tree. So a couple of photos may be missing the faces itself, right? So we don't want to give that to training. We don't want to show a tree and say this is Anand, right? That's why we are checking to make sure, is there a face? Yes, then continue, otherwise return none. Yeah. So then we are calling the embedder, which is the ResNet, and then we are processing it. We are generating the whole embeddings, and then I am sending back the return. I am sending the embeddings, and then I am converting. I use NumPy methods just to ensure it goes in the proper matrix numerical format. Right? Once the embeddings are generated, now we have to load the data set. Right? Why we have to load the data set? We have kept it in a very nice folder, faces. Under that, Praveen, Sujay, Abhiram, or if you are doing it, let's say you have your mom, dad, brother, sister, their names. All those folders are there in a specific format. How do I read all these pictures? Very easy, right? 2 loops, loop within a loop. That's it. So I'm going to load the data set by saying for person in folder. So each folder becomes a person. So first folder is Praveen, so it will take Praveen as the name of the person. And 1 second, sorry, yeah, this is the second loop which is inside. Sorry, there's a little too much code, so and it's also doing some checks, right? If it is not a valid path, sometimes what happens, you will find a folder which is like .ds_store or some .ini. On Macs it will be a default folder. On Windows there will be some .ini or .git. Some folders will be there. Those folders you can skip, like if there's not a valid one, then just move on. Same thing we'll do with the files, but this time once you read the first file, image1.jpg, or like Sagar in Himalayas.jpg, whatever the file name is, right? Load the file and call the get embedding method, right? Get embedding, what it does, if you remember, get embedding taking the image that is given, then it is calling MTCNN, detecting the face, also converting RGB to BGR, and then it is converting that to embeddings. Simple, right? So that's what I'm doing. Get embedding of image 1. Then again loop will continue. Pick the second image. Now this time let's say Somu is sitting on a Harley Davidson and he has taken a picture, right? It will still detect exactly only his face part, and then call the embedding, generate the embeddings. Also you keep appending that to X. If you remember basics of machine learning or deep learning, every single program you'll have X and you'll have Y. X is your input, or also called as features. Y is your output or the predictions, right? So now I am adding all the X, means input features is nothing but your embeddings. And what is Y? Y is the person name that we pulled out of the load data set here. Means first folder's name was Sujay, second folder's name was Abhiram, like that. It is picking that up. Now I'm adding Abhiram's embeddings here will correspond to Abhiram's name, right? Sujay's embeddings will correspond to Sujay's name. Shashank's embeddings will correspond to Shashank's name. And then I'm going to return both X and Y as NumPy arrays. Why NumPy arrays? Because your whole CNN is just a vectors or matrices of numbers. Yeah. So once that is done, we will now have to train the model. Yeah. So and then we'll also save the model. So that's very easy. Load data set we already looked at. Here's where the program actually starts. All these while we are writing functions which are not executed. And then here, first of all, I'm going to do a normalization, basic your fit transform. It will try to look at converting all of them to a same sizes or formats and everything else. And it will give you back X in a more normalized format. The numbers will get slightly changed, modified. We don't care internally what it does. Right? So now I will be calling support vector classifier SVC for training the model to classify this embeddings belongs to Sujay, this embeddings belongs to Pravi, this embedding belongs to Abhiram. Right? Once the model is trained, this line will take time, right? It will keep running. Folder 1 found, 20 images found, folder 2 found, 20 images found, like that it will go on. If you have a GPU, it will be fast. If you have a CPU, this line will run for a bit more time. And then we are going to dump this model's weights into a file. I'm calling it as FaceNet underscore svm.pkl. You can call it whatever you want. You can say, like Raj's family or Sukesh friends.pkl. It's up to you. Yeah? And then it will print training is complete. I want to just let the user know that, hey, the training was complete. There were total 5 samples used, is what is happening here. Yeah? So that's the whole thing that happened there. Now let us move to the coding itself. I hope you guys can see my coding window. I'll turn off the camera so that you can let me see what's in the code. Okay, this is YOLO v5 which we did last time. I hope you guys remember this. We will create a new not folder, we'll create a new file. Let me call it as train phases.py. okay, here as well we'll write the code. I'll close this just for the sake of confusion. And yeah, okay, all right. So let's recap what was the first step. We have what, like 15 minutes. I'll try to do as fast as I can, otherwise we'll copy paste some of those. Import numpy as np, this you guys know. Import OS, why are we doing it? To go through each and files and folders, so that is import OS. Numpy as np, as I mentioned. Then we need Python image library. Yeah, sorry, what was that? From pil import, I have to do image. Yeah, okay. Then I need normalization, so that's in sklearn. From sklearn dot preprocessing import normalizer, right? I think, yeah. Then from sklearn dot, what do we need? svc, right? So for that I need to call svm import svc. Now, okay, MTCNN and inception ResNet. This we need for detecting the face and also creating the embeddings. I'll see if I can share this code in the chat. Let me see if that works. Let me check how does this work. Oops, paste. Did I copy? Oh, okay. I think it works. I'm able to paste it. Yeah, that's good. Then I also need, I forgot to add torch. What's the last one we need? Job lib, right? Yeah, these are all the imports. Yeah. Now next, if you remember, we need device, right? Let me just copy paste that. Yeah, device is equal to torch.device of CUDA. If I already explained this, if you have GPU, it will return the value as CUDA, otherwise it will return it as CPU. So it will use whatever is there, it will not throw an error, because if you don't add this and if you try to call a method that is specific to GPU, then it will throw an error that GPU not found. Then this is the MTCNN which I mentioned, and then next is we have to do the embedded. I mean, it's just a variable. I'm going to do inception ResNet v1 of pre-trained VGG face. Yeah, so that takes care of that. Let me add all of this code to the chat window so far. Everything, I hope. Oh, it's not allowing me to paste. Sorry about that. Okay, I'll have to take only. Okay, one of the things I can do, guys, is I will upload the code also and give you a link in the comments, and I'll pin the code so that you'll be able to follow through. Otherwise, you can just come back to the video, run it, and pause it, and then follow through. Yeah. So the next one, again keeping time in mind, we have get embedding, right? So def get underscore embedding. What we pass here, image path, right? I think we'll call it imgpath. Yeah. Let me copy paste the code so that. Yeah, the first one is to create a, pass the MTCNN, the image that was passed, and convert it to RGB, which I explained earlier. And if there is no face detected, we want to return none. Then we will make sure that the embedder, we generate the embeddings, and then we have to return it, right? So we'll just call the return method, and then we'll pass the EMB, which is nothing but the return embeddings, and I'm using NumPy as I mentioned you, so that it can go as numbers. Yeah. So let's now look at load data set, right? Load underscore data set, and for that again we have to pass the folder. Okay. So I'll just copy paste. I just want to show you the output also. So as I explained in the code, I'm passing X and Y, creating two empty lists first. X is the input, Y is the output. Right now nothing is there. I'm going to loop through for person in os.list directory of folder. The folder that is passed, list the directories, get all the folder names, and assign it to the variable called person. That's the name of all the people. If you go to faces here, Abhiram is there, Chirag is there, Praveen, Sagar, Sujay. For Abhiram in for person in os.list of folder, first it will pick Abhiram and put it in person. Then the person path is os.path.join. If you remember the slide, slash faces slash Abhiram slash whatever is the first file name here, 1.jpg, right? So that's there. And then I'm doing the check. If there is no valid folder, then continue, or no valid file, continue, like that. And I'm now going through each file inside the folder, like Chirag's folder, Praveen's folder. I can click on each of these and show the pictures. You can see my photo there. And then you keep appending them to X and Y, then returning the NumPy array. So that finishes your load data set, right? Then finally, right, I have to actually execute this. When I call this line X comma Y is equal to load data set of faces, it will take this load data set method. Folder is nothing but faces, which I just passed, and then it will loop through everything and assign the persons and all that variables and all. Then I will call the normalizer, because as you understand normalization, a giraffe is very big, a chicken is very small, a coconut tree is big, alligator is smaller than that. If I have to get pictures of all of them in 24 by 24 or 32 by 32, I would normalize, right? I would standardize, I would bring them all to same pixel, something similar, converting the numbers between 0 and 1. Everything becomes 0.2, 0.3, 0.7, 0.44, like that. That's normalization that we are doing. Then now we'll call the classifier support vector machine. So for that I'll have to say model is equal to SVC, and here I'm passing some variables. Kernel is equal to linear. This kernel is nothing but your classifiers, CNN's kernels. Then probability equals true, balanced weights, and the fit method is what executes this command. So it's going to actually start adjusting all the weights. If you know how neural networks generally work, the first round random weights are assigned and calculated, and it will be wrong. The difference will be the error, the loss function that will be sent back, and it will keep adjusting the weights again and again and again to finally get back. So something similar. Internally, the fit method does a lot of things, and finally that will generate the model, right? After that, we will save this whole weights into a file. Like I said, I'm calling it as FaceNet underscore svm.pkl. If you want, you can say friends, or my underscore friends.pkl, right? It's fine, whatever you want to call it. Oops, sorry. What happened? Yeah. So one of the things generally we do is we also give some info. Actually, more information the better. I'm just saying print training is complete. Len of X, so many, 5 samples used, 10 samples used, whatever the number of samples were used, that we will be telling. So let me just see if I can get back the, yeah, presentation. Where are you? Yeah. So what happened here is we collected the photographs first, then we created an empty folder called faces, then we organized and aligned it like this. That's why the import OS, and these were the folders as I showed you. Then all these raw photos, cropping, resizing, augmentation was all done. Then yeah, MTCNN and FaceNet, all that we did. And let me go back to my code. Okay, now I hope you guys can see my window. Let me just remove this. Yeah, so the next step is prediction, right? Once we did all the training and saved, prediction is simple. Same libraries, import CV2, import PIL, image. CV2 is OpenCV. This is for me to open the camera and start detecting the faces. Then PyTorch, NumPy, JobLib. Why JobLib? Because I want to load the this one, FaceNet SVM augmented.pkl. Oh, sorry, augmented is the augmented, the other one which I have improved by adding more thing. I can also use the FaceNet SVM model PKL also. So what I'm doing is GPU or CPU I'm checking first. After that, MTCNN object I'm creating. I'm also creating the embedder, which is for ResNet, and finally I'm loading the trained model here. Next, this is what we are doing in prediction, right? So we will say cap is equal to CV2 dot video capture. What it does, it will open the webcam, right? And CV2 is your OpenCV. Dot video capture of 0 is my first camera. I may have connected multiple cameras, like you're seeing me already on a camera. My laptop has a camera. So of 0 tells me to use the default camera, which is from the laptop. I'm setting the frame width and height, which it should cut and take, and then send it to the normalizer, which will convert. So now, while true means always keep running until I do something. You keep reading all the frames, cap.read. Then I am now converting the BGR to RGB. If you remember earlier also we did dot convert of RGB. Here, since I am already having CV2, it has a inbuilt function called color underscore BGR to RGB, and then I am getting the detected faces, which will be put into a array called boxes, and x1, y1, x2, y2 is nothing but the edges, like left, top and right bottom. Will be the x1 and y1 for the box. Then it will do a crop. Why? Because we don't want everything else. We don't even want the hairs, right? We don't want a cycle that is standing behind the person. We detect the face, we crop the face and use that face only. Yeah. Then yeah, just looking at time, we are running out of time. So I want to first run and show you guys this and see how it works. Then what we do is we are, for the new face that comes in a camera, we will take the embeddings. First crop the image, send it for embeddings, generate embeddings, and then send it for prediction. So it will do a search, and until I press Q, this will keep running. So let me run this. I'll share the code for prediction, and I'll have to share the new window. Okay, wow, it is detecting me. But for you guys to see that, I'll have to share my screen. Mac OS screen capture. Okay. And I'll use a window. What is that called? Python face recognition. Yeah, I found it. Okay. I hope you guys can see me now. If you can see me, you can also notice that there is a rectangle on my face. I'll move to the left or I'll move to the right. The box is following me because every movement, every frame is getting captured, being sent to CV2. That is, CV2 is capturing every frame and it is sending to MTCNN. MTCNN is finding my face every time. Like if I move completely far right, I'm still in the frame. So it found my face, it put a box there, right? If I come again back to center, MTCNN is putting the box. On top of it, the box is sent, or the face part is sent to my trained model, or before the trained model, the ResNet. ResNet will generate embeddings now, right now while I'm speaking. It is generating the embeddings, and that embeddings is getting stored in an array, then comparison with the array that was stored in the PKL file. Now this values and this values, they'll do a similarity search, and then it will say, oh, what is the percentage confidence? 91% confident that this is Praveen. Let's try Sagar also, because I've trained him, his face. Sagar, you are showing in red because you're far off. Start coming closer. Let's see. I hope it's a good percentage. 85, 90 something, 87. Cool. So, and if you guys can notice, both of us being in the frame, it is detecting both of us. And when the confidence is low, it's red. Once the confidence increases, it is showing in. I've just coded like that, but you can do it however. Yeah. So thank you, Sagar, for that. Now I will stop sharing this, and I hope that was good. Let me stop this. Yeah. Okay. Yeah. All right, guys. So it kind of is already 5 o'clock. I will share the source code. This is completely working. This is the source code with some added comments. I will share the one. This has a few comments, and I've also added the augmentation, which I did not explain there. But the one that I wrote now is here. Train faces. This is the same code. It just does not have the comments. I'll share both somewhere so that you guys can download, and I hope it works. So just to recap, just give me 1 second. All right. Okay, let me stop this. I don't need to show that. Yeah. Okay, guys. So anyway, coming back to the session, I hope this was useful. I hope you guys learned about face recognition, what it is, how it works, and we talked about the detection versus recognition. Then we also talked about the applications, like in surveillance, airport security, social media tagging, and unlocking your phones and all that stuff, retail, customer experience. Then we went through the whole process of training and prediction, which are two separate modules. We were able to look through line by line of training and prediction. A little bit we saw, some more lines are there that I'll be sharing. And what we did was we collected the photographs, put them in the folders, ran through the files, created the embeddings. Before that, we detected the faces using MTCNN, called ResNet, created embeddings, saved them, gave the labels, and then we predicted that. So that's what we did today, and it worked. And I want you guys also to try it and let me know, were you able to do successfully? If you're facing any errors or challenges, message me on WhatsApp if you have my contact. Otherwise, put a comment in YouTube, and hope that is helpful. Yeah. Thank you so much, everyone, and you guys have a wonderful day. Bye-bye.